we are very close to the end of this module. I don't think we even get to lesson 40. It stops somewhere in the high 30s.
38.
Something like that, just because we're throwing kind of an extra practice lesson in at the end of the week, so I'm not sure what number we would call that. But anyway, lesson 36, I can multiply 2-digit by 2-digit numbers. That's something we started yesterday. Using 4 partial products. Notice what it doesn't say. It doesn't say that one of our numbers is going to be a multiple of 10. So we're not going to have that number that always has a 0 today. Okay, and we're going to see how the area model changes slightly because of that. And then we're going to pull in this other way to do 2-digit by 2-digit multiplication with partial products. So today we're actually going to see 2 different ways side by side. Okay, and again, you might be deciding, hey, I like this area model. This is going to help me, or hey, I like partial products. That's the way that I want, that I like, that I know how to do. You may like all the ways that we do. You may not care for any of the ways, but I will say it's important that you learn this because this is a skill you're going to need. I use it all the time as a grown-up. I used it probably every year after I learned it in school. So this is important. Okay. All right, we're going to warm up just a bit. So grab your marker. All right, we are going to not look at the bottom here because some of these methods we don't know, but I do want us to use the standard algorithm, the regular way we've done it the most, and divide 406 by 7. Let's just get 1 or 2 practice problems to get us warmed up here. 406 divided by 7. Okay. Sevens can get out of 40. If you know your sevens well, you flew through this. Okay. The thing that's slowing some of us down is our sevens. How many sevens can we get out of 40? What's the most sevens that we can get out of 40? Okay, we're to the point we kind of need to automatically know this. Yeah. What is 7 times 5?
35.
Okay, let's go here. So 5 sevens is 35. This is what tells me how many groups of 7. This is what it is when it's multiplied. Okay? All right, we subtract.
5.
Okay, make sure you're watching this to see if you followed these steps and got these steps correct. Bring down that 5, or subtract and get that 5. Bring down the 6. All right, a bell should go off. A light should come on. That is a fact family right there. Will, what's the number that's missing?
8.
Okay, 7 times 8 is 56. If we can get that number exactly, that's what we want. We want to get that whole number if we can. most of the time we have to get just as close as we can. But if we can get that actual number, that's what we want. We subtract it, nothing left here and nothing to bring down, so we're done. And our answer is 58. Let's check it with multiplication. 7 times 8 is 56. 7 times 5 is 35, plus 5 more is 40. And we have 406, which is our dividend right there. Okay. Alrighty. Let's try one more. Actually, I don't know why I did that. I'm going to need the space anyway, so let me just come back here and write it for you. 3,168 divided by everybody's favorite.
9.
There we go. May not be our favorite, but it is one we need to practice. So we know we can't get a group of 9 out of 3. We know we're going to have to look at 31. That doesn't ring a bell for any fact family, but we can get close. So what's the closest we can get to 31? Yeah.
You could get 9. You could get 9 3s out of 31, and it'd be 27.
Okay, so 3 9s. I gotcha.
And
I knew what you meant. Okay, so we can get 3 groups of 9. 3 groups of 9 is 27. That's as close as we can get because 4 groups of 9 is 36. It's too big. Okay? When we subtract, you're going to have to borrow. I have people that get in here and they have a problem like this and they have to subtract and they get lazy and they almost do it. They do it backwards sometimes. You can't do that. You got to do your regular old borrowing here. 11 take away 7 is 4. Bring down the 6. Okay, no fact family there, but I know one of my 9s gets really close to that. What 9 gets really close? Yeah.
5.
9 times 5 is what?
55.
Not 55, but
45.
45. Okay. Okay. Oh, and I see a fact family falling into place right there. Okay. That doesn't always happen, but it does a lot. Yeah. Okay, 9 times 2 is 18. We subtract that and get 0. Nothing else to bring down. So if we're going to check it, 352 times 9. 9 times 2 is 18. 9 times 5 is 45, 46. 9 times 3 is 27, 28, 29, 30, 31. And there we go. Okay. All right, hopefully Even if we just did one of these a day, I think it would keep us fresh and keep us remembering how to do this. Guys, we've worked way too hard on this to lose this skill. We want to keep this. Plus, when you go to 5th grade, I don't want you to have to start from scratch, you know. I want you to bring this knowledge with you and build on it, because you'll do a lot more with it when you get to 5th grade, okay? All right, good job. Let's look at one of these. This is different. Okay, now, I'm changing on my computer, and I know what I'm talking about, but you can't see my computer. So, there we go. Okay. All right. Now, they've written this differently today. They've written it vertically. Okay. What did we do with a problem like this yesterday? Yeah, what did we do?
We did a rectangle.
Mm-hmm. What was that called? Do you remember? What model did we use yesterday?
Area.
Yeah, area model. Okay, so let's draw a rectangle. Remember, kind of like the 3 bears, we don't want it too large, we don't want it too small. We want to be able to write in the boxes. Okay, if you were not here yesterday, please make sure you're listening. All right, we took the 30 and we put it on the side. We took that multiple of 10 number and we put it on the side. Okay, yeah, go ahead and be doing this with me. I'm glad you started that. What went across the top? What went across the top? Help me know how to write that. Isabel, what would I put? Okay, how would I write that? Would I write it as one number? Or I'm going to pull it apart, remember? And we had 2 pieces. We had the 20. And then we had the 3. Okay, we're going to pull it apart until it has its 10s and its 1s. It's still 23. It's just pulled apart. Okay. Because what that does is that lets me multiply smaller chunks instead of all these big numbers at once. Okay? What am I going to multiply that goes in this box? What is going to be my math equation, my math problem, Miranda?
30 times 20.
Yeah, 30 times 20. So write that in there. Okay, 30 times 20. Then what will the math equation or math problem be right here next door? Alexandria, what would it be? 30 times 3. I'm going to have to squish that a little bit. Okay. So now I'm going to write the answer to each of those. Each of those is a little simpler. Okay, what we started doing in 2nd period, somebody mentioned this and we just started doing this, so if this helps you. When we multiplied 30 times 20, we circled the digits that were not zeros and multiplied those. So what's 3 times 2, everybody? 6. And then we added the zeros. There are 2 zeros, so 600 is our answer. Okay. Sometimes it helps folks that have something to see, and circling those numbers just helps people see that better. All right, we could do the same thing here. Circle those 2 3s. Everybody, what's 3 times 3?
9.
Okay, 9. How many zeros are we adding? 1. So we've got 600. We've got 90. Valerie, what do we do with those 2 answers? The 600 and the 90. What do we do with those? We add them together. Okay, so we came over to the side and added those. Pretty easy. You could add those probably in your head. But 690 was your final answer. Okay. Now that's just kind of warming us up because we're going to take that area model today. We're going to change it just slightly. Yeah.
Can you check this?
Can we check this? Could we check our 690? What do you think?
No. We could do division, but we would have to know how to do 2.
That's the thing right now is this. It would require a two-digit divisor. Guys, you really could do a 2-digit divisor the same way you do a 1-digit divisor. It's just larger, and we're just not as used to working with those larger numbers yet. So Yes, there is a way. I think that would be more difficult for us than doing this. So, all right. Let's move on then. We are ready to jump in. Let me make sure. Yeah, that's. You know what? I am going to slow down just for a second. I do want us to try this. I do remember seeing this yesterday. It just feels like forever ago. Okay. One problem here on the bottom. If you ever see a number like that and then it's got that wavy equal sign, what are they wanting you to do? Yeah.
About how much it is.
Okay. That means about how much, which is telling us to round. And they want us to round
To the nearest 100,000.
nearest 100,000. So if you would first write this number on your board, you can even do the wiggly equal sign. It just looks like two ocean waves beside each other. Yeah. Okay, just hang on then. Get that number written down. And we're going to round it to the nearest 100,000. Okay. Some of us have gotten even better at this, and some of us are still figuring it out. Rounding just takes a little bit. Part of the trick right now, or trick, I say trick, but part of it right now is just copying this down correctly. Okay, what digit is in the 100,000's place? Brandon, what digit is in the 100,000's place?
5.
The 5. So find that 5 and put your target above it. Okay, nobody's an expert at this, so please do this. Okay, where are we going to draw an arrow? Yeah.
To the 2.
To the 2. We're going to the right, not to the wrong. Okay. What's so important about the 2? Yeah.
It's the number beside it.
Okay. But what does it do?
It tells us if it's under 5. If it's under 5, we round down. If it's over 5, then we round up.
Okay. You know, how many of you ever played baseball
Me.
or softball? I don't know if this happens in softball. I know it happens in baseball. My husband's been a coach for several years. My sons have played. Okay, you can put your hands down. You ever watch the coach and they're standing over there beside the dugout on the third base line, and then they start doing this
Yeah.
kind of stuff? Okay.
Signs
They're
means
giving signs.
steal.
But one of their signs is called an indicator. One of their signs, like maybe it's this, and the coach has already told the team. He might say, okay, guys, whatever I do after this, that's what you pay attention to. All this other stuff they do is just to throw the other team off. They might pat their head. I mean, they do all kinds of crazy looking stuff.
Mm-hmm.
But they might say, hey, this is my indicator. When I touch my nose, the very next thing I do is telling you what you need to do. Okay? And so that 2 becomes like an indicator. It's like it's telling the 5 what to do.
It decides where it goes.
It decides where it goes. I like how you said that. All right, so is that 5 going to stay a 5 or is it going to go up to a 6? That's what we've got to decide. Faith, what's it going to do?
Stay at 5.
It's going to stay a 5 because the 2 is not large enough. If that 2 was a 5 or more, it would change it. So our number is we got to keep the 4. We got to keep this stuff. We're going to keep the 5. But from that arrow all the way over,
It's
They're
all
gonna-
zeros.
yeah, and that's 1, 2, 3, 4, 5 zeros. I like to make sure I count them when there's that many. Woo, where do we put the commas? We start on this end, and every 3 digits we put a comma. Okay. And there is our answer.
I wonder what it's like in the division column on a million number.
The same way, just longer.
Can we do it?
Not now.
Aww.
Okay. All right. I do want you to put the top on your marker and lay it down. I do want you to really pay attention to how this is going to change. This is the way we're going to do the area model most of the time. Okay? All right, lay that down. Go ahead and do that. So we have 34 times 35. Okay? Now, I know that it says partial product up here. But partial product and area model kind of work closely together sometimes, and that's why we're doing them together. Okay. So I'm actually, let me switch over because I feel like I'm going to need more space. I don't want that to look so crowded for you. We've got 34 times 35. Okay. We are still going to have our box, our area model. But remember yesterday how we crossed off this thing over here on our problem set? We're going to be using it today. Okay? Make sure there's no markers. No, I want the top on your marker right now. We are going to do one just in a little bit. Okay. Now there are no multiples of 10, but I have two numbers that are 2 digits each. So I'm going to need a ones and a tens place for both of those numbers. So my rectangle is now going to be cut more than once. Okay? All right. So that's how that has changed. Now I'm going to put both of these on the sides. But this time I am going to pull apart both numbers. Okay? Pulling apart both numbers. So 34, we'll put it over here. It really doesn't matter which number you put on the top or the side. Okay, I'm going to go ahead and tell you that. I usually grab the first one and put it here and the second one and put it here. That's just a habit that I have. But could I put the numbers on the opposite sides and it still work out? Yes. Okay. So I'm going to grab 34 and I'm going to put 30 and 4. You see how we broke that apart into the tens and the ones. Okay. Across the top, we're going to put 30 and 5. All I did was break those numbers apart. Okay. Now I'm going to do the same thing I did yesterday, and I'm going to put the math problem or the math equation in each box. But I'm going to look at each of these boxes separately. This box is going to be 30 times 30. Okay. This box is 30. That much is 30. 30 times what?
5.
Times 5. Okay. This box here is not 30 in width anymore. It's 4, isn't it? So it's going to be 4 times 30. Okay. And this box here is 4 times 5. Okay. Now look at that for a second. It's not real different from yesterday. It's just more boxes. Okay. Anybody have a question as to how we got this so far? Okay, so now we would just put the answer for each of them. 30 times 30, well, 3 times 3 is what, everybody? 9. How many zeros are there? 2. So that answer is 900. Okay. 30 times 5, well, we've got a 3 times a 5 is what? 15. Plus 1 0 is 150. Okay. 4 times, if they're lined up right, you can still do that, but sometimes that zero's in the way. It's hard to make that box. What's 4 times 3? What's 4 times 3? 12. Plus 1 0 is 120. What's 4 times 5, everybody? 20.
25.
Okay, now, this is where partial product starts, okay? I say it's where it starts. This is where it kind of turns into partial product, okay? 900. Actually, let me reverse that. It's not really where partial product starts. This step is in partial product. Let me say it that way. We've got 900, we've got 150. We've got 120, and we've got 20. We're ready to add up all those pieces. Now we don't have 2 things to add up. We've got 4 things to add up. So what would be really important to remember right here, right now? Look at that stack of numbers.
To make sure
Okay. Make sure they're what?
like you know how to add correctly.
Like okay, we want to add them correctly.
You have to be able to line your numbers.
We've got to line them up correctly. Okay. Okay, that's going to be 0. This is 5 plus 2 plus 2 would be 9. 9 plus 1 and 1 is 11. So there's our final answer. Okay. Now, I'm going to shrink this a little bit.
Shrink.
Yep.
Bye-bye.
I'm actually going to move it over, and I'm going to put the whole partial product process on the side. Let me just separate it right here so we don't get anything confused. Now let's say that I'm going to use partial product, and I do 35 times 34. Okay, because eventually you're going to see the problems stacked vertically like that, and that's how we're going to do them. Okay, now this is not standard algebra, this is partial product. Okay? All right, are you watching? Let me get rid of that. Partial product, I'm going to write out here to the side what I'm doing. We saw this before. Okay? All right, we start here in the ones place on the bottom always. Okay? 4 times 5 okay, is 20. Heard that behind me. Okay? All right, here we go. Be careful. Watch this. I think we did this when we did 1-digit multiplication. 4 times 30. Okay? 4 times 30, and this is where you can easily sometimes put that box. 4 times 3 is 12, and 1 0. I almost moved my 2 over too much, didn't I? Can you see that? In fact, that's going to drive me crazy. There. Okay. Now, we're done with the bottom. We're done with the 4. Now it's the 3's turn. Okay, this is where it's different. Before, we didn't have another digit. The 4 has gone to the 5. The 4 has gone to the 3, or it's actually a 30. Okay? Listen, guys. Now we go to the next digit on the bottom. The 3 is going to go to the 1's place up here, and then the 3 is going to go to the 10's place. Okay, so we're going to have 30. Remember that 3 is actually a 30.
Yes, sir.
30 times 5. 30 times 5. We've got our 3 and our 5 are 15 plus 1 0. And now we're going to do the 30 times 30. 30 times 30. Because there's 3 10s here and there's 3 10s here. What is 30 times 30? 9. And then 2 zeros. And we're going to add it all up. 2 and 2 and 5 is 9. And then that's... Alright, we've gotten the same answer, haven't we?
Yes, ma'am.
Now, I want you to look at those 2 ways to do this. And I want you to tell me, is there anything similar? Is there anything different? What do you notice about those 2 ways to do this? Look at them carefully. Look at all the parts and pieces. What do we notice? What's something you notice?
In both of them, we have to add a lot of numbers.
Okay, in both of them, we add all the parts up. What's another thing you notice?
They all have the same multiplication problems.
Okay, look at these multiplications. problems. 4 times 5, 4 times 30, 30 times 5, 30 times 30. 4 times 5, 4 times 30, 30 times 5, 30 times 30. Same multiplication problems. What else?
When you add them up, they're flipped around.
And that just happened. Yeah, 20, 120, 150, 900, 20, 120, 150, 900. Okay. If I would have changed these numbers around, or, it could have been in a little different order, but even if it would have been in a different order,
You could still get the same answer.
Same answers, yes. Okay. So partial product does not have the rectangles. That's really the main difference. This one has this to look at, which helps some people.
Are we gonna be using
Some people are visual learners and need that rectangle. It helps them. Okay. I'm one of those. But I've used that kind of thinking so much that now I can do this without the rectangle. Okay. Our problem set today is going to ask you to do both. At first, it's going to ask you to do both together, and then it's going to ask you to stop using the rectangle, the area model, and just try it without it. Okay, so we're going to practice some of that so we can give this a try. Okay? Yeah.
I learned to the rectangle. It's easier for me.
And that might be the way that you like the best out of these two. I hope down the road that we all like the standard algorithm also. It is way faster, but sometimes we need this first before we get faster, I got really fast with my training wheels on my bike before we ever took them off. You know what I'm saying? Like, I was really fast. Like, it's kind of like, all right, really, Wendy, wait, it's time to take them off, And then I was ready to go without them. But sometimes we need something like that to help us along.
I learned to ride a bike without anybody.
Yeah, sometimes you don't need them at all. Okay, we're going to walk through this step by step together. Okay? What I would like for you to do is to cut your board in half so that you have a side for area model and a side for partial product. Okay. All right, so on this side, we're going to start with the area model, and we're going to have 26 times 34. When I do a multiplication problem, I'm always going to put my larger number on top when they're stacked vertically. All right, we'll do that partial product problem in a little bit. Okay? On our area model side, we're going to need a rectangle. You know what? I got to have room to write beside my rectangle. So if you've made it all the way over to the line, you're going to need to make it a little smaller.
Are we dividing?
Nope. Notice these are 2-digit numbers we're multiplying. That's why we've cut this side into 2 pieces and this side into 2 pieces. A piece for each digit of the number. Okay? All right. I realize some of you are going to have to write tiny. Okay? All right, we're going to take 26 and we're going to put it over here. But we're pulling it apart. 20 and 6. Okay, if you don't have room to write on the side, you're going to need to make room. Okay. Okay, I would erase that and scoot it over just a little bit. 34, 30, and 4. Okay. All right, we're just going to do the area model, and then we'll move over to the partial product in a minute. Okay. All right. So now we start filling the boxes with the math problems. Okay. So in this first box, what's our problem going to be?
20 times 30.
20 times 30. Because it's the length times the width.
And what is it
Okay.
equal?
What about the next box beside it?
20 times 4.
20 times 4. We know this piece is 20, and up here this little piece is 4. Okay. All right, I need to stop and ask this question. Are you understanding, are you getting where we're getting these numbers from?
Yeah.
This little piece is 20. This little piece is 6. This little piece is 30. This little piece is 4. Okay? Right, in this box, what would the problem be? 6 times 30. Okay. And in this box, what would we have? Yeah. 6 times 4. Okay. Alright, so we have all of our problems. Now we just need the answers. Okay. 20 times 30. Well, we've got a 2 and we've got a 3, which is 6, plus 2 zeros. 1, 2. Okay. 20 times 4. 2 times 4 is 8, plus a 0. Okay, understand where we're getting this. Don't just copy the board. That does nothing for you. What's the next problem we're going to need? It's 60 or 6 times 30. What's that answer going to be?
180.
Yeah, 6 times 3 is 18, plus the 1 0. Okay, 180. What about 6 times 4, everybody?
24.
24. Okay. Okay. What have we got to do with all those pieces now? Add them up. Okay, add them up. I like to write them in the order of their size. The biggest number first, then the next. That way, if one is longer, it goes up top and makes it easy to line up all the other numbers. So 600, 180, 80, and 24. Could I mix those up?
Yeah.
I could, but it would be a whole lot harder to line them up just right with the ones places and the tens places and all that. Okay, go ahead and add those up. Usually the numbers that you add on these pieces are not hard to add. Okay, what did we come up with? 884. That's 16, 17, 18. 884. That is correct. Okay. Okay, let's go to the other side and see how this works. Okay, we did partial product one other time before, so it is similar. We're going to start in this bottom corner, and the 6 goes to the 4. Let's put out beside that 6 times 4. Yeah. Okay. Make sure you're writing that down. What is 6 times 4?
24.
24. Line it up with your numbers. So the 6 has gone to the 4. Now the 6 goes to this digit, but this is not a 3. It's a what?
30.
Okay. So 6 times 30. I've got the answers already over here. I'm not going to let it take me super long to figure out the answers because they're already over here. So let that help you, okay? No sense in doing it twice. Even though some of these become easy to do quickly anyway. Okay, now we are ready to look at the 2. The 2 is going to go to the 4 first. But it's not actually a 2. What is that?
20.
It's a 20 times 4.
And the answer is 80.
Okay.
I had no idea.
And then this 2, which is really a 20, is going to go here. This is a 20. What is this actually? A 30. So it's 20 times 30.
600.
Okay. Now, do you see how when I wrote my answers this time,
It's reversed.
but look at my numbers. I had a 2-digit, then a 3-digit, then a 2-digit, then a 3-digit. That's not what I'm getting at, guys. Listen. Line up your numbers correctly. I had somebody yesterday, I did it as a joke to see if they could see why I did it wrong yesterday. Right after I did that, somebody next door, they got the totally wrong answer because they had lined up their numbers. Let's say they did this. And they just started adding. Are you going to get the right answer there?
No.
Not a bit. Not a bit.
Try.
Okay, you've got to line up your ones place, you've got to line up your tens places, and your hundreds places. Okay. All right, when we add all that up, we should get this, but let's make sure we do. We're adding here. 10, 18, and that is 884. Okay. Now, if you had to pick right now, and I know we're just starting some of this, if you had to pick right now, would you rather do area model or would you rather do partial product with no rectangle? If you like this way better, raise your hand. I just like to see. Okay? If you like this way better, raise your hand. Okay? It's always interesting to me to see who likes what. Okay? All right. So we're going to get rid of that. Go ahead and clear your board. We're going to try one more. Now what's nice today is this is not 100% brand new. It's just we're adding on to some things we've already learned. Okay? All right, here's our problem. Go ahead and split your board again. Okay. Wait a minute. That's the one I need. Okay. So we're going to do 38 times 43. Over here it will look like 43 times 38. We know both of those, doesn't matter the order, we'll get the same answer. But it's a good practice to get into to put your larger number on top when you're multiplying it vertically. Okay? Alright, let's start over here. Draw your rectangle large enough, but you got to have some room on the side. Remember that. Okay? And we're going to cut it one time this way, and we're going to cut it one time this way. Okay? We're going to put each number on one of the sides. We're going to put 30 and 8. And we're going to put 40 and 3.
Are we going to do this for our problem set?
Oh, yeah.
Yeah. Are we doing an
We're doing both ways for our problem set.
We're doing an exit too? On computer?
It's similar to yesterday where they give you some area models, you choose the right one, but then they also give you some problems and you'll work it out on Scratchpad. Okay. Now we're ready. This seems like it takes a long time, but none of these steps is overly difficult. Okay? Now you just need to write your problem in each box. Okay? So what's going to go here? What's going to go here? 30 times 40. Now I realize the exit ticket, remember how it just had the answers in there? But right now we need to make sure we know where the answers have come from. What's the math problem that got us there? Okay. What's this math problem going to be? Let me ask Bailey, what am I going to put here? 30 times 3. Okay, Brandon, what am I going to put in this box?
8 times 40.
Good. 8 times 40. Gage, what am I going to put in this little box? The length here and the width here. What's the length here? 8. And what's the width here? Okay, 8 times 3. I guess because the way I line up my numbers, the ones place, this tends to be the smallest problem. It's because it's both ones place numbers. Okay. All right, go ahead and put your answers in there. Times 40. You've got a 3 times a 4 is 12 and 2 zeros to add. Okay. A 30 times 3, you've got 2 3s, which is 9. 3 times 3 is 9 and 1 0 to add. Okay. 8 times 40, you've got an 8 times a 4, which is 32, and 1 0 to add. And then 8 times 3, everybody is 24. Okay, go beside it and add those up. If you don't have room beside it, maybe you do underneath it, but we need to add up all 4 of these numbers. 1200, 320, 90, and 24. Please line up your numbers correctly. That is something so simple and yet can really make us have the wrong answer. All right, we add those numbers. $1,634. Okay. 1,634. Make sure. Let's see why it's fixed. Okay, take a breath. We're gonna jump over to the other side.
I want to do the cheesy face.
You want to do the cheesy face?
No.
Go right ahead. Okay.
The
Nice.
cheesy face.
8 times 3. Write that right here. 8 times 3. You know that's 24. Then the 8 is going to go to the 4, but it's not a 4. It's a
40.
because that 4 is sitting in the tens place. It's a 40. It's not really a 4. 8 times 40. 320. I'm going to have to shoot some of my numbers out farther to keep my places lined up. Okay. Ouch. All right, this 3 is actually a 30 because I've moved over to the tens place. So 30 times 3.
And then 3 times 3.
And it's actually not a 3. This is a 30 times 40 because the 4 is in the tens place. So 30 times 40.
And that equals.
Now, this one gets hard. I hate when this happens. That's just me. I've got these numbers, and this one goes all the way to the thousands place. I'm going to have to be careful how I write that so my numbers are lined up. Because it's the number 1200. If you know that, you might want to write it backwards so that it lines up with all your other numbers. Your ones place and your tens place and your hundreds. Okay? Alright, and then we just add them up. Okay.
34,634.
Okay, I want to do something just because I just want to do it. No. I want you to be able to see both ways. Okay. I want you to put the top on your marker for right now. Okay. Some of you are already kind of there, and that's why I'm doing this. Okay, yeah. Alright. This is not coming for another day or so, but here's standard algorithm. I want you to see the difference. Okay? 8 times 3 is 24. I put the 4, I carry the 2. You know what? I like to change colors. Hold on. It just helps us see it better sometimes. Okay. And then 8 times 4 is 32, 33, 34. Now, up until now, that's just like the standard algorithm we already know. When I get ready to go to my next digit over, I have to always put a 0 right there. It's kind of like a placeholder because now I'm fixing to multiply with the tens place. I need my numbers to be just a little bit larger because they're moved over a place. That right there, that 0, is one of the things that gets people messed up because they forget it. All right, here we go. 3 times 3 is 9. 3 times 4 is 12. Add them up. And I'm done. Okay.
Whoa.
That is standard algorithm. It's a lot less work than all of this. And all of this. Same answer. Okay. What was I going to tell you? When you have a longer problem like this, sometimes it's just more room for error, and we don't want that to happen. Yeah.
When you add 4 times 4 plus 9 and you carry the 1, you didn't add the 1 that you put there.
Yeah. 1 plus 3 is 4, 5, 6.
Oh.
And the only way I knew I did it fast because the answer matched over there. This, yeah, all this kind of looks a little messy. I was in a hurry. That's the plus sign. Okay. All right, so just wanted you to see this is what's coming. So if you prefer things like this, maybe you've already kind of had a touch of this already, know a little bit about this already, and you're ready to get there. Be patient. We will. By the end of this week, we will be there. Let's see. Actually, I think we do start it tomorrow. I think we do. We like put it with partial product tomorrow. It's like tomorrow we kind of drop off area model and we do the 2 other partial product and standard algorithm. The next day we drop everything and we're just at standard algorithm. So just be patient. The whole reason we do lots of methods is because y'all are different. Y'all are different kinds of learners. Some of you learn best by hearing. Some of you learn best by seeing. Some of you learn best by having like things in your hands and learning that way. Some of you learn best with a variety of all those ways. And so we're trying to show you lots of ways to help different learners. That's one of the whole reasons we do this. All right, clear your board. We are going to start our problem set in just a minute when we get back from our restroom break. Okay. I'm actually going to leave this on the board, I think, just to remind us of what steps to take, minus that. I don't want that to confuse anybody. So, let me unfreeze. Hold on. No, I've shrunk things before. I don't know if I can stretch them back out. I feel like I can. Maybe I have done that before. Okay, a little easier to see then. Okay. All right, so you can lay your workbook on your desk. That's fine. I'll let you know what problems we're doing when we come back. we will do most of them, but I'll double check it when we come back.